Hello everyone, welcome back. Today we are going to be working on proofs using SSS congruence theorem. So what is SSS congruence theorem? Well, SSS stands for side, 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 because essentially what the theorem says is that if all three sides of one triangle are congruent to all three sides of a second triangle, then the two triangles overall are congruent, right? So essentially what this is saying is that automatically if all the sides are congruent, all the angles must be congruent as well, like just automatically, and therefore the triangles overall are congruent. Or in math terms, for example, if AB and DE are congruent, so these two are congruent, and BC and DF are congruent, so these two are congruent. Or sorry, I think this should say BC and EF. It says DF for some reason. This should be EF, my apologies. And then AC and DF are congruent, so these two here are congruent. Then that means that overall the triangles are congruent, that ABC is congruent to DEF. So let's do an example with SSS congruence theorem where we can apply this theorem after, with the two-column proof. So here it says, given that AB is congruent to BD, which we can see is marked here, these two are congruent is given, and that AC is congruent to CD, also given, prove that the triangles are congruent. So before I get into the two-column proof, I first want to just talk a little bit about how do we know fundamentally that this is true? Well, we know that if we can find some way to prove that all three sides are congruent, that would be enough. That would prove that the triangles overall are congruent. We've already been given two sides, so we just really have to prove that the third side is congruent to the third side. So we just have to prove really that BC is congruent to itself, because BC is actually a shared third side for both. Now, because of reflexive property, we know this is true, right? Recall that reflexive property states that any side length is congruent to itself, right? So therefore, that is enough information to prove it. That's really the only thing we need to do other than what's given. Now I'll write out the formal proof. First, I'm going to write out what's given, which is that AB is congruent to BD, and my justification is that it's given. Also, AC is congruent to CD is also given. And then BC is congruent to itself. And if BC is congruent to itself, that's using reflexive property. And now we have met all the criteria for using SSS congruence theorem. We've proven that all three sides of one triangle are congruent to all three sides of another. So therefore we can say by SSS, or side, 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 congruence theorem, that therefore ABC is congruent to DBC. And there we have it.